A little housekeeping up top as we get going. We are recording this session just so everybody is aware, although attendees, we are not able to see or hear you. Everyone is coming onto the line muted. You will be able to ask questions through the Q&A function on the right side of your WebEx screen there. We will address those on the fly as we are able, and anything we aren't able to do that way, we will address at the end, and we're happy to stay until all questions are answered. We will not be handing out the slides of this presentation, but we have something that I think is actually more useful. It's a written companion piece that goes over some of this information and links to all of the sources that we have. Last, we are going to cover a lot of information today. Any subject here could be its own 30-minute presentation. So we are happy to go on a one-on-one deeper dive on any of these subjects with you or your organization at any time. Just reach out to me or anyone at Willdan, and we're happy to figure that out. A little bit about Willdan as we get started. If you're not familiar with us, we are a full-service engineering and construction management firm. We've been helping clients get more performance from their buildings for over 50 years. And Willdan Performance Engineering really specializes in holistic major renovations of existing buildings and infrastructure. Another thing I should let you know up top is probably clear from that previous slide, but we are an engineering firm, not healthcare professionals. We are giving engineering advice, not medical advice. Another caveat I should give is that I think a lot of you are here today to learn more about safer, healthier buildings in the context of COVID-19. COVID-19 is something that we continue to learn more about. There's a lot of uncertainty about COVID-19 and how much and how fast it spreads. So we're here to talk about safer, healthier buildings more generally. The advice that we have will apply to COVID-19, but we're able to say exactly how much with a little bit less certainty. So why did we decide to put this presentation together? Well, actually for some of you, if you're between the Rocky Mountains and the Pacific Ocean, something like this picture might look familiar. I'm sitting in Seattle, Washington. This is our view of the Space Needle from a couple of weeks ago. We had some of the worst air quality in the world. We're essentially here today to talk about indoor air quality. There are a lot of recommendations we're going to have today that will make your building safer and healthier from a smoke event situation. There are some of those will be complementary to safer, healthier buildings regarding infectious disease. Some of those are going to be opposite, but we're happy to kind of point those out as we go through. I think more likely most of you are here today because we are in the middle of a global pandemic, and we're all kind of being bombarded with these kind of silver bullet product pushing kinds of reach outs from folks. This is a real spam email that I got on the bottom there. We're in a situation where information is changing really fast. It's difficult to understand who to listen to and what to do. And at the same time, I think what we're seeing is a real lack of clarity from every level of government, state, federal, county. We're going to look just at the federal guidelines today because this is a presentation for everybody. But I can tell you that it's not much better at the state or county level in the areas that we work. The Centers for Disease Control, they have some recommendations on how to safely reopen buildings, and they recognize that the HVAC systems and building engineered systems are essential in maintaining safer, healthier buildings, but they don't really help you figure out what to do next. And I kind of sympathize with them. It's very difficult to talk in a general sense about every building type because every building is different. But when I read this, I see that there's a lot of language like consider, in consultation with, improve, or increase. I don't know when I've improved something or in what I need to increase to what. It's just not very actionable. There's a couple of concrete suggestions in here that I can run with and actually go apply to my building. But generally, it's more about what you should do and not really so much about how you should do it. So what we're here to do today is to try and give you some actionable advice and some real next steps for you and your building. I think that, I know the folks that we work with are kind of feeling like this, generally feeling overwhelmed with a lot of new information and requirements being put on them, working to make those administrative interventions to create safer, healthier spaces. So those are things like social distancing rules, mask policies, putting up plexiglass barriers, things like that. Those are all very important. And actually, many of them are more important than the building engineered systems we're going to discuss today. But we're hearing from lots of folks right now, some specific questions about specific building engineered systems, and just this general question of how can we know what to do in our buildings to make them safer and healthier? Who really knows about this stuff, and how can we apply it to our buildings? And that's kind of what we're here to do today. We want you to feel like you're going from this to more like this. We want to help you understand how healthcare facility managers think about controlling infection inside their buildings and creating safer, healthier standards. And I'm here to tell you it's probably more realistic than you think. It sounds like it might be a tall task, but we're going to look at some of the healthcare standards for building engineered systems and how we might apply them to your buildings. And the good news is that this is not new science. Like I said, this is not just about COVID-19. Healthcare professionals have been thinking about how building engineered systems can make safer, healthier buildings for 100 years or more. And the reason that they do that is that hospital-acquired infections are deadly, they are common, and they are preventable. So this is a field that a lot of smart people have been looking at for a long time. There's a lot of peer-reviewed research and professional standards that we can draw on and apply to our own buildings, and that's what we're here to help you do. So we're going to look at how infection spreads inside buildings, how to control that spread, and some specific building systems that we can use to create safer, healthier buildings. And again, I'm hoping that you leave here today with some specific ideas of what to do next inside your building. We are going to cover a lot of ground, and so we will recap and recommend to the best of our ability what you should be doing next in your building. So let's start by looking at how infection spreads. So really what we're looking at here is how do people get other people sick? This is not just about COVID, this is just how people get other people sick. So it all starts with someone that is infected, they cough, they sneeze, or they touch their face, their ears, eyes, nose, or mouth. And then there's 3 ways that they will expose a susceptible host and perhaps make them infected. The first way is called direct spread via droplets, that's here in the middle. This is the most common way people get other people sick, and when someone sneezes or coughs, droplets are expelled, they hit somebody else, they are exposed, they could become infected. Droplets are heavier than air. They typically travel about 6 to 10 feet, kind of depends a little bit, but 6 to 10 feet is about how far they travel before they fall to the ground. This is the easiest of the 3 things to control. The next way that people get other people sick is through indirect spread, through contaminated surfaces. Somebody sneezes or coughs, touches their ears, eyes, nose, or mouth, and then touches another surface. Droplets hit a surface, that surface is contaminated. The droplets actually aren't called droplets anymore, they're called fomites. This is a less common way that people get other people sick, but it is absolutely possible. An infected person deposits fomites, a susceptible host touches that surface, touches their own ears, eyes, nose, or mouth, they are exposed, they can become sick. The last way that people get other people sick is through airborne droplet nuclei. Now, this is the toughest one to control, but as droplets are expelled, some of them immediately evaporate and become droplet nuclei. Other droplets or fomites will evaporate over time and become airborne. Droplet nuclei rather, they are lighter than air. They're not a gas, but they're able to float and suspend in the air. They can travel great distances. Especially for a virus, the droplet nuclei are going to remain viable for a much longer time than droplets or fomites. Again, we are still learning about COVID-19, but I think the trend of evidence is that COVID-19 is an airborne virus and that airborne spread is possible and that it's something that we need to think about preventing in order to create safer, healthier buildings in our communities. Most of the building engineered systems we're here to talk about are going to help us control airborne spread. We can help with everything a little bit. It just so happens that most of the building engineered systems are able to address airborne spread more effectively than some of these other types of spread. So now that we know how people get other people sick, what can we do about it? Well, the first thing we want to do is think about droplets. The first thing you want to do is contain droplets. So you want to prevent them from traveling. You do this through wearing masks, plexiglass barriers, things like that. The second thing you want to do is maintain droplets. You want droplets to remain droplets instead of becoming airborne nuclei. You also want to reduce the float time of droplets by maintaining or increasing their mass and causing them to fall to the ground or to a surface as quickly as possible. We'll talk about some ways you can do those things. When we talk about indirect spread through fomites on surfaces, you want to inactivate particles on those surfaces. The most common way you're going to do that is through your cleaning regimen, your janitorial staff, or I think more and more everybody is part of the janitorial staff these days. But it's conceptually very straightforward. You clean surfaces and you inactivate particles on those surfaces. We're also going to look at a couple of building systems that can help us do that. Last, when we talk about airborne spread through droplet nuclei, again, the first thing you want to do is prevent aerosolization. Keep droplets droplets. Once droplets become airborne droplet nuclei, you want to first dilute the air that those nuclei are in. So that's reducing the dose that a susceptible host is exposed to. And next, you can disinfect the air, so destroy infectious disease that's inside that air. And we'll look at specific building systems that will help us do all of that. But let's look at some specific building system strategies and kind of the frequently asked questions we're getting out in the field right now. The first question we're going to talk about is ventilation. The question we're getting is, should we have 100% outdoor air in our buildings? Well, let's look at a couple of different spaces and see how they compare to healthcare standards. So let's start with a typical classroom example. A typical classroom that conforms to the most current international mechanical code, you would expect that classroom to have at least 3 outdoor air changes per hour in that space. Depending on the HVAC system type, if you have a system type that is recirculating some of that air, you would expect a total ventilation rate in around 6 to 8 total air changes per hour. Now, a couple of big caveats here. This is assuming a newer building that's designed to the current international mechanical code, or whatever your local code is. They're usually based or close to the international mechanical code. It's also assuming that your building is operating as designed. Now, I can say in the case of schools, I would be shocked if the building fell into either of these categories. We know from building surveys that the Department of Education does that about half of all school buildings in the country don't meet their local code standards, and that even more of those buildings are not functioning the way they were designed. Unfortunately, we commonly go into brand new buildings that aren't operating as they were designed. It's for a variety of reasons. And also, buildings are modified slowly over time, and they tend to slip farther and farther away from their design specifications. So most buildings are not meeting current code, either because they weren't designed that way or because they are not maintained that way, or were never built that way in the first place. But schools do have a relatively high amount of outdoor air already. If we look at a different example, kind of on the other end of the spectrum, an open office, so kind of a typical medium-sized, say 2,000 square foot open office, International Mechanical Code might only require a half of an air change per hour for outside air in that space. The amount of total ventilation in that space is going to vary a lot depending on where the space is, the occupation density, what time of year it is. But you might expect between 5 and 10 total air changes per hour in that open office. Generally speaking, you will have more outdoor air in your space if you have a higher density of occupants. So classrooms are highly dense compared to most other spaces. You have a lot of people in a small amount of space. So you're going to have more outdoor air. Total ventilation is more a function of the heating and cooling load. If you have a high demand for heating and cooling in a space, you're going to be turning air over more frequently in that space in order to meet that load. So your total ventilation rate will go up. We don't have time to get into all of the types of HVAC systems that are out there. Some of them are 100% outdoor air. They don't recycle air. Some of them are recycling air, recirculating air more than others. Different system types will have different abilities to change the amount of total outdoor air and total ventilation. But keeping these two examples in mind, let's look at healthcare standards and see what we can learn. So these are the ASHRAE standards for sensitive healthcare spaces. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. It's the professional body for heating and cooling engineers in the United States. And ASHRAE sets minimum standards for sensitive healthcare spaces. Well, actually for every healthcare space, but we're looking today at the sensitive spaces, the places where surgery is happening, where sensitive operations are taking place, or where very sick people are located. So here we have the minimum outdoor air changes per hour required per space by ASHRAE. We also have another column for all room air exhausted directly to outdoors. Now that implies 100% makeup air or 100% outdoor air being supplied to that space. And do we have 100% outdoor air supplied to sensitive healthcare areas? The answer is no. We have between 2 and 4 outdoor air changes per hour for all of the sensitive healthcare spaces, and most of them are not requiring air to be directly exhausted to the outdoors. Some of those spaces that do require air to be directly exhausted to the outdoors are actually unoccupied, the medical gas storage space. That requirement is not so much about human health as about general safety. Looking at total ventilation required in sensitive healthcare spaces by ASHRAE, now keeping in mind that our offices or our schools are probably in the 5 to 10 total air change per hour range, depending on what type of HVAC system they have. Well, that's going to cover most of the sensitive healthcare areas. That's going to cover, the trauma room, the critical and intensive care room. It's going to cover many of these areas. So you might be wondering, why doesn't ASHRAE require, you can see here in the cesarean room, 20 air changes per hour? Why wouldn't they require that everywhere? Well, the fact is that there is a cost to supplying ventilation, and there's only a certain amount of benefit that you get from it. So the costs associated with supplying more ventilation are the increased equipment cost to be able to supply that ventilation, the increased energy cost to run that equipment, and then there's other effects that aren't necessarily to do with the HVAC equipment. If you have 20 air changes per hour in a space, it's not going to be a silent air change. So you might not want 20 air changes per hour someplace like a classroom where people are trying to concentrate. So those are kind of on the cost side. What about the benefits? How can we understand those? Well, there's a lot of different peer-reviewed studies that we could pull. I pulled one to kind of give us a way to think about it. This study asks the question, if we have a very sick student that's infected with something that's highly airborne, so some forms of tuberculosis, for example, are like this, and that student is sharing a classroom with their colleagues for an 8-hour school day, how many other students are likely to become infected? You can see on the left side of the table here that with no ventilation in that space, it's very likely that a lot of the other students are going to become infected. As we start to introduce ventilation to that space, we see a sharp drop in the proportion of students infected. As we get to 3 air changes per hour, there's a very sharp drop here. As we go from 3 to 6 air changes per hour, there's another drop, but the drop is not nearly as sharp. And as we go from 6 to 9 to 12, we continue to see small drops in the proportion of students infected, but they're really not very big. It really starts to level off. So you kind of stop seeing a return on your investment in increased ventilation right here around 6 air changes per hour. So that's maybe one reason that ASHRAE would not have 20 air changes per hour required in every space. So should you increase ventilation in your building? Well, I don't know you and I don't know your building yet, but my answer is going to be probably. If I had to guess, I would say that it's very likely that your building was designed to supply insufficient ventilation for a safer, healthier space. That's kind of our open office situation. Um, it was designed to an older standard that's insufficient, or it's no longer operating as designed. I think most of you are going to fall into one of those 3 buckets. So what should you do? Well, if your building is newer than 2005, you've got relatively new equipment in there, you're designed to a relatively newer standard, I recommend recommissioning your building. Work with your existing HVAC service provider or an engineering expert like Wildan to help you understand what your building was designed to do. Is it actually doing it? And what options you have for making changes in the case that you decide that changes are a good idea. If your building is older than 2005, your equipment probably has, 5 to 15 years left on it, but a lot of equipment, it's going to go about 20 years before it's recommended to be changed out. So now is the time to be thinking about, okay, what do I have and what do I want my next set of equipment to look like? I know that working in facilities means you're generally chronically underfunded and understaffed, but we've never had this much attention paid to these sorts of subjects as we have now. And so it's kind of a golden opportunity for you to work with an expert and figure out, okay, what do I have now and what should be my plan moving forward? What I don't recommend you do is that you climb up onto your roof and go find your rooftop units or go to your DOAS unit and try and force more outdoor air into the space. HVAC systems are complex, which means they're highly interconnected. If you make a change in one part of the system, you will be making changes to other parts of the system, probably in a negative way and with unintended consequences. Any changes you make in your HVAC system should be careful and deliberate, and you should understand what the effects will be. So that's kind of our FAQ out in the field right now. Should we have 100% outdoor air? There's other things that we recommend that you do that we're not necessarily asked about very often right now. So this slide is going to present all of the ventilation tactics which we recommend. First, we recommend that you disable or modify your demand controlled ventilation. There's a variety of ways to provide demand controlled ventilation. One common one is through a CO2 sensor, which will sense when a space becomes occupied as CO2 builds up in the room. We recommend that you either disable that or lower the set point on it. You don't want a lag time between when a space is occupied and when ventilation starts. You want that ventilation to be running as soon as the space is occupied. That's how you get a safer, healthier building. We recommend that you flush your buildings. We have actually gotten questions, should I have my ventilation running 24/7? We don't think that's a good return on your investment, but we do recommend running your HVAC system, running your ventilation for at least 2 hours before occupancy and 2 hours after occupancy to make sure that everybody's starting with a clean slate in that building. Keep your bathroom windows shut, your toilet seats down, and your exhaust fans on. If you have exhaust fans in your bathroom, those rooms were designed to exhaust everything to the outdoors and not push air into the surrounding rooms. So it sounds a little counterintuitive because I know it feels like you're increasing ventilation to open bathroom windows, but really don't do that. You will change the room balance and you could be pushing bathroom air into adjacent spaces, which you don't want. If you don't have exhaust fans in your bathrooms or they're not functioning right now, opening the windows will help, but you really should have mechanical ventilation in those spaces. Also, regarding toilets, we're learning more that flushing a toilet, if someone is infected and they flush a toilet after use, that it can aerosolize and spread infection inside that room. So encouraging your occupants to keep their toilet seats down or installing toilet seats where they're not present is a really simple and easy way to help help reduce the spread of infection inside your building. We talked on this, but it is very important. If you don't have mechanical ventilation in your building, this is a lot of older buildings, you really should. There's a reason it's code. You're going to go a long ways towards a safer, healthier space by going from no ventilation to some ventilation. And there are several different ways you can do this. If you have a newer building, I highly encourage you to make sure your building is working as designed. A good or retro commissioning of your building should pay for itself in a pretty short amount of time through the energy savings. You're going to have more comfortable occupants. You're going to have fewer hot and cold calls, fewer complaints, and you're going to be creating a safer, healthier space. If you're not sure where to start, we actually have a self-perform checklist on our blog. It was tailored around reopening your building safely. So there's some things in there like paying attention to prevention of Legionella that might not be applicable to you. But in addition to those reopening steps, it's going to cover all of the steps that you should be thinking about in understanding where your current HVAC system is at. Next building system strategy we're going to discuss is enhanced filtration. The question we're getting out in the field is, should we have HEPA filters on everything? That sounds like a good idea. And I get it. It sounds like a really easy, cheap, fast intervention. You put in HEPA filters everywhere, boom, safer, healthier spacers. But the way filters work is they restrict airflow. So if you go from a lower, like say a MERV 8 to a HEPA or even to a higher MERV rated filter, you're going to be reducing airflow in that unit. You're likely to create unconditioned spaces in your building, which is not good for human health either. You've now eliminated the fresh air supply to that space. People are getting hot or they're getting cold. You're likely to be damaging your equipment if you just pop in a better filter. Equipment was spec'd to work with a certain filter rating. And again, as you increase your filtration level, you're getting diminishing returns on that investment. So let's look at healthcare requirements for filtration and how we can understand costs and benefits to increase filtration. So we're looking back at the ASHRAE standards here. Does ASHRAE require HEPA filtration in healthcare spaces? The answer is almost all in all the most sensitive spaces, no, with one exception. The protective environment room is where you find the most sensitive patients. This is maybe stage 4 cancer patients, bone marrow transplants, things like that. You can see that in every other of the sensitive hospital spaces, a MERV 7, a MERV 13, or a MERV 14 is going to put you to hospital standards for filtration according to ASHRAE. Now, why might that be? Again, you have increased costs and diminishing returns as you improve your filters. So let's look at that in a couple of different ways with some peer-reviewed studies. Here we have the effectiveness of filters on viruses, filter efficiency versus particles of different sizes. Virus droplet nuclei are generally about zero point 0.3 to 10 micrometers. Now, if you're concerned about smoke, which again, I think a lot of us are, I know I am, smoke can be highly variable in size. It can be way down here. It can be smaller than zero point 0.1 micrometers. It can be bigger than 10. It's going to kind of cover this whole graph. The droplet nuclei are going to be here in this blue shaded range. But what we can see here is that as we move from MERV6 to MERV16, we do see higher filter efficiency, but especially around MERV14, we start to see real diminishing returns on our investment. Going from 14 to 15 to 16 doesn't make a big jump, and at least that's what they observed in this study. Let's look at it a slightly different way, plotting efficacy against cost. So this study, what we can see is they were looking specifically at that size of airborne nuclei, 0.3 to 10 micrometers. As we move from MERV4 to MERV14, we see sharp drops in our relative risk of infection and very small increases in the annual cost of operating that filter. That is both replacement cost and energy cost. As we move from MERV14 to HEPA, we can see that we have very small reductions in the relative risk of infection, but now we're starting to see sharp increases in our cost. So what I would conclude from this graph is that MERV13, MERV14 is kind of our sweet spot. So should you increase filtration in your building? I'm going to again say probably. I don't know you and I don't know your building, but if I had to guess, I would guess you have MERV8 in your building. That is what most design engineers specify to protect the equipment, not necessarily specified to protect human health. If you think this is you, and if you're not sure, it's relatively easy to go check your filters and see what they're rated at. Consult your HVAC technician, your current service provider, or an engineering consultant like Willdan. There are solutions. There are generally ways to, there are a variety of ways that you can increase filtration safely in your system, but don't just go pop in better filters. You're asking for trouble. Alternatively, there is a way that you can make a MERV8 filter behave the equivalent of a MERV13 filter, and we're going to talk about how to do that in our next section. How to disinfect air and surfaces. The question we're getting the most in the field right now around this is, should we install UV lights? UV lights are something that most people are familiar with, but there are a variety of ways that building engineered systems can disinfect your air and surfaces. We're actually not big fans of UV light. So you're going to see here at the bottom different ways you can install these systems. This is UV light inside a room designed to operate in an unoccupied space. This is UV in an air handler. This is UV in a duct. UV light is generally less effective at disinfecting air and surfaces, regardless of where it is, whether you're trying to do that inside a coil, inside a duct, or inside a room. It's also less safe for people and materials. This is UV light inside an occupied space. You have to be very careful how you design those systems, that you're not exposing people to UV light. Also, UV is highly degrading to a variety of materials, and you can cause real damage in your spaces or in your HVAC systems by renovating with UV light. UV light also has quite high operation and maintenance costs compared to some of the other options. One other option you might have heard of is ionized hydrogen peroxide. This is this kind of misting option you see here on the bottom right. Disadvantage of this is that there's relatively high cost because you have to hire and train someone to do this, and you're using labor versus an automated engineered building system. This is an expensive way to disinfect, generally overkill for most buildings. And what we really recommend, kind of hands down for most people, is bipolar ionization. And let's talk about why that is. Bipolar ionization is the safest and most effective way to disinfect both air and surfaces inside your spaces. The pushback we sometimes get on this is that ionizers create ozone. Older types of ionizers did when these first were kind of around in the 1980s. It's a long way since the 1980s. Ionizers should be UL listed to be ozone free. That's UL 867. Look for an ionizer that has that rating. Ionizers are going to be able to control a variety of particles that are harmful to human health: pollen, dust, smoke, etc. They control odors. They are highly effective at destroying viruses and killing bacteria and mold spores. What's more, unlike UV lights, which are absolutely going to increase your energy demand, there is an opportunity for bipolar ionization to lower your energy demand. The energy demand of the units is very, very low. And if you have an HVAC system where you're recirculating air, you can actually recirculate more air with a bipolar ionizer, which means that you're having to condition less outdoor air, which is generally speaking going to lower your energy bills unless you're only bringing in 70-degree outdoor air, but that's not very likely for most of the year. Overall, bipolar ionization is cheaper to install, operate, and maintain than the other options. What's more, that is the way that you can make your MERV 8 function like a MERV 13. There's some pretty recent research from the National Research Council of Canada, and what they observed is that if you take your MERV 8 filter and combine it with a bipolar ionizer, you get the effectiveness of a MERV 13 filter. That's because these ions latch onto particles in the airstream and make them bigger and make it easier for the filter to catch them. The MERV 12 plus bipolar ionization gets you to a MERV 16. That's like having an N95 mask on your building. Generally speaking, bipolar ionization adds 4 or 5 steps to your MERV filter rating. The last thing we're going to cover in this section is how do we know if any of this is working? You know, we've got enhanced cleaning protocols. Devin, you're here telling us bipolar ionization is a great way to disinfect air and surfaces. How do we know that that is working? Well, we work with a partner called IWC Innovations. They have a system of rapid testing and certification that your spaces are COVID-free. They're the only ones that we know of that are able to provide this. And so I mentioned that here because it's a question we're getting out in the field. That is a good option for you. The last building system strategy we're going to discuss is humidity. It's one of the most important factors in creating safer, healthier buildings. There's actually not an ASHRAE standard around this for hospitals yet, although we expect that could change in the next ASHRAE iteration. There's actually there's mounting peer-reviewed evidence as well as mounting pressure to make these standards universal. A lot of hospitals are already implementing their own standards of having at least 40% relative humidity in their sensitive spaces. I'm not aware of many upper bound limits on humidity. You do want to have your humidity between 40 and 60%. That's the ideal range for people. If you go higher, you get mold and dust mite problems. You go lower, you get problems with viruses and other human health problems. Dry air is more likely to be a problem for more people. Even here in Western Washington, when we bring moist air in from the outside and we condition it for a space, we're drying that air out. It's not always. I think operating rooms, for example, are very typically too wet because they're trying to be kept very cold as well. But generally speaking, dry air is more of a problem. There are multiple benefits of having more than 40% relative humidity in your space. First of all, you're going to give the immune system of your building occupants the best chance possible to fight off infection, and that's actually really important. We're talking about, the mucus system staying nice and moist so it's able to capture and expel things. Remember, we want droplets to stay droplets. If you have dry air, droplets will become airborne droplet nuclei more easily. And viruses especially, they really like dry air. Viruses can stay viable and be able to infect people much, much longer in dry air than in moist air. There is a variety of peer-reviewed studies I could have pulled to illustrate this point. I'm just going to kind of touch on one, and that is a study that I looked at that showed that when a K-12 environment introduced humidification to some of its classrooms, they reduced the spread of flu by 75%. And I believe they took the relative humidity from 20 to 70%. So that's just, that's for all of these reasons over here on the left, you're seeing reduced chance of infection in those spaces. Now, is humidity right for you? It's a really tough question to answer. Humidification and dehumidification systems are expensive to install and operate, and they're difficult to maintain. We go into a lot of spaces, even healthcare spaces, that might have their humidification system turned off because it's expensive and difficult to keep running properly. So there's a lot of caveats to those. You see some spaces, we work with museums, for example, they care a lot about relative humidity, not for human health reasons, but for archival reasons. It's not the right answer for everybody, but it's very important. What we're understanding more and more as we do more research is how important it is. So we needed to touch on it in this presentation. So I am hoping to leave everybody with a to-do list and for them to understand what steps they can take for safer, healthier buildings. So let's try and recap everything, and then we'll go into some questions. Get your building to current standards. If you've got an older building, it's probably built to an older standard. We see a lot of courthouses, for example, that have no mechanical ventilation. The ventilation system is to open a window. That's 100% outdoor air, but you're not getting a very high ventilation rate with that open window. So work with a professional like Wildan to understand what you can do to get to current standards. Start planning now. I highly recommend that you get your building, you ensure that your building is operating as it was designed. Again, most are not. And if you have something like an office building, see what options you have to increase your ventilation. Again, do this in consultation with your existing HVAC service provider or with an expert like Wildan. Check your controls. These are all of those options for flushing your building, um, disabling demand controlled ventilation, all of those things that we talked about. That's something you should be able to do in a house relatively simply. Upgrade to MERV 13 and install bipolar ionization. Again, do this in consultation with your existing service provider or an expert like Wildan. And last, tell your community. You may have heard the term hygiene theater. That's where you do things that are very obvious, but they're not very effective at keeping people safe. I encourage you to not do these things. I encourage you to do things that are effective and find ways to effectively communicate that to your building occupants and your community. So Wildan is actually underway with several projects to implement all these types of technology that we talked about today. And what we do as part of our projects is to create a custom communication plan for every client. So that would include custom signage to call out things that are normally invisible to folks inside of a building. We create verbiage and communication strategies around email distribution, press releases, updating your website, doing web trainings with staff, newsletter articles, etc. It's part of the full service that we provide. And, the problem is we don't have a silver bullet for any of this stuff, but we do have a lot of silver BBs we can employ. But it is tricky to communicate what's being done and how we know it's effective to our communities. But I highly encourage that you do that. Don't engage in hygiene theater. A couple of examples just to kind of go over it. I think what I want you to understand is that these building interventions can be done in any type of building anywhere in the country. The top right here, this is an historic courthouse here in Washington State. Doesn't currently have mechanical ventilation. We were already in progress with a project there, and we are now working to implement some of these COVID strategies in that courthouse. This bottom right, this is a K-12 client in Colorado that we have a longstanding relationship with. We've worked in a variety of their buildings. This is the high school, middle school, and we are implementing some of those strategies there. And then the bottom left here, this is a municipal client in the Midwest that we've also worked with for many years, and we're working to help them implement some of these strategies. And then just to help you understand how unobtrusive they are, I've got a couple of examples here. This is a bipolar ionizer unit retrofitted into existing ductwork. Touchless controls are a really simple and relatively inexpensive way to control the spread of fomites. You're probably familiar with touchless lighting, touchless faucets, flushes, things like that. Well, here's a touchless door control, a little bit less common, so that's the one that I selected to put in there. Last, I would be a little bit remiss if I didn't talk about how to pay for it all. Again, I understand that working in facilities means you're ordinarily chronically underfunded and understaffed. Wildan works with our clients to fund projects in a variety of ways. I'm not going to go over every part of this slide. Just understand that there are many options out there. Work with someone that knows how to find you the money. The only one I'm going to point out is federal funding here at the bottom. And the reason I'm going to point this out is that Wildan did a lot of projects under the last Downturn Recovery Act, the American Recovery and Reinvestment Act. And what we found is that you're a lot more likely to get funding if you have a plan, if you are quote unquote shovel ready. So we recommend that you make your plan now because it's pretty likely that there will be some funding for some of these strategies in the near future, whether it's called stimulus or infrastructure, COVID recovery, any of those things. You need to get yourself ready. If you are shovel ready, you're a lot more likely to get funding. And what you don't want to do is pull something off the shelf that's the closest thing you have to ready, even though it's something that's not your first choice. So work with an expert like Wildan to understand what you have now and where you should be going, make a scope, make a budget. In closing, every building is unique. We did our best to cover a variety of situations today, but really you need to tailor every intervention to your unique situation. Always make those changes with an outside expert or your existing service provider, someone like Wildan or your existing technician. We can't, unfortunately, make buildings 100% safe, but we absolutely can make them safer. I know y'all are out there feeling like this, but you really can get to this. Thank you very much, and we're happy to address any questions that you still have.
Okay, Devin, we've had some great questions in the Q&A, so I'm going to start lobbing them to you and Danny. The first question comes from John, who's with Duke Energy, and he's in North Carolina. And I think, Danny, I might throw this your way initially. The question is, Duke Energy offers a program called Energy Wise. It provides Wi-Fi thermostats free of charge to customers who agree to have Duke control their thermostats at set intervals throughout the year. It is designed to cut off the AC unit for a business. Is this not a good idea? The design is to cut down on demand during peak times. So maybe Danny, you want to handle that one first?
Yeah, it's kind of a it depends question. Depending on your system, it sounds like that's a program that probably does space temperature setbacks during peak demand periods. And if they're just like during cooling, if they're just setting thermostats from like 72 to 78 during a peak demand, it would depend on the system type and whether or not the supply fan is designed to run continuously to provide ventilation, regardless of whether or not it's in heating or cooling mode. If it's a system that cycles on and off as heating or cooling is needed, it's probably not a great idea during these COVID times, because then you would be turning the fan off more during those peak demand periods and not providing your ventilation air. If it's a system where the supply fans can continue to run and provide the minimum ventilation rates they're designed to provide, just like without the compressors or cooling coils being on or for heating also, if they can continue to provide the ventilation at those increased space temperature set points, that would be fine. Then you're still maintaining ventilation.
Okay. Just to give you another add-on, Danny, John said that they're cutting off the HVAC completely for 18 minutes for 4 hours, for example. Just in case, just some background.
Completely for 18 minutes. Oh, during like a 4-hour window, they cut it off for 18 minutes total. I think it's still, that gets tricky. It's a very specific case. It's still a bit of a, it depends. Can they, during those times, have doors or windows open to get fresh air in the space? Is it a single 18-minute window they're turning off, or is it a few minutes here and there over those 4 hours? If it's just kind of cycling the systems, that may be acceptable, but that you are reducing the ventilation rates. And so that's just something to be aware of. It would depend if they're over ventilating the space to begin with also. Yeah, it's kind of, during these times you want to be maintaining those air changes per hour, like Devin talked about, that kind of minimum of 3. And so it's kind of, it's hard to answer that without saying it depends.
Right. And John did add that they are not maintaining ventilation, just as
okay.
So.
Yeah, maybe Danny, we could connect with Duke Energy afterwards and kind of dive into those details more. It is a pretty specific situation. I mean, generally speaking, if you turn off ventilation, you are reducing the safety and health in the building. By how much, and is that worth it? That's a harder question to answer.
Yeah.
So that's something maybe we can look at in more detail, specifically kind of offline.
Perfect. Okay. Well, I have another question from Stephen in San Diego. His question is, can bipolar ionization in our system alleviate the need to put in UV lights we would normally specify for clean AHU coils only, rather than airstream disinfection?
Yes.
And his additional question then also is, can BP ionization system, can it be used in lieu of a UVC lamp immediately downstream of the cooling coil of an air handler?
Yes. So I think I can answer that question, and Danny, go ahead and jump in if you feel like I've missed something. But generally speaking, ionizers are going to do a much better job at cleaning coils than UV light. Light moves in a line, and UV lights actually struggle to reach deep within the coil. ions kind of float freely within the air and are able to penetrate more deeply and actually do a better job at cleaning the coil than UV light. Depending on what the run of the duct is to the space, ions tend to degrade pretty rapidly. So you might want to have a second ionizer nearer the space downstream from the air handler to project ions into the space and be cleaning air and surfaces in that space. So it depends a little bit, but we really do kind of hands down recommend BPI over UV light for essentially any application.
Agreed.
Okay. One more question here from Ken. He states, you recommended not opening restroom windows. What are thoughts about leaving exterior doors and or office windows open during the pandemic?
It's a good question. Yeah. So let's say you have no ventilation in your space. Opening doors and windows is going to help because going from nothing to something is better. You're probably, if we think about air changes per hour in those spaces, opening a window, what's your air change per hour going to be? A quarter? Not very much. It is better than nothing. But if you do have mechanical ventilation in your space, it was designed and balanced to run a certain way. So opening doors and windows can work counter to that. And actually from there, I would hand it over to Danny to maybe say more, but I'm going to say it depends.
Yeah, it's definitely it depends. If the system wasn't designed to provide proper ventilation or is under ventilating spaces, it might not be a bad idea to have windows and doors to the exterior opened. But if you've got a decent working system in place, you're probably providing more air changes per hour and better conditioning the space by leaving those doors and windows closed.
I think we went through our list of questions. If you have any more questions, please feel free to put them in the Q&A because I think we got through our list.
Great. And again, we're happy to go over any of this one-on-one with you, or if you wanted to do a deeper dive into any of these subjects, or maybe you've got colleagues that weren't able to join today, but you'd like to kind of do this live in person. We're happy to do that with you. We do have that companion piece that we can circulate on request. And if you're interested in learning more about this stuff and making some specific changes to your systems, we are pretty much nationwide. And so we have people near you. So feel free to reach out. And thank you, everybody, for joining us today.